Okay, here we go. So for Prop 7 here, we'll talk about a disease, cystic fibrosis. Is inherited from parents only if both parents have the abnormal big CF gene. Okay, notice that the small CF and big CF are different. Okay, if you got the big CF gene, I mean you are definitely, you have that cystic fibrosis gene. Children of two parents, and by the way, of course, that's the dad and that's the mom.
Oh my god. I love the mom and the grandpa.
I thought they were
No, sorry. They need to update the picture. No, I'm sorry. But, of course, this inside this box right here are the possibility of, children. Whether you're going to be the carrier, or you're going to be infected, or you're not going to be infected and not a carrier at all. We'll see what's going to happen. But, of course, if you have the small CF, that means you are not infected. If you have the big CF, oh, yeah, there's a good chance that you get infected with the cystic fibrosis disease. Okay, so here it is. Children of two parents with CF gene will either be affected with the disease, a carrier but not affected, or not have the gene. So we have like three possible scenarios. And yesterday we learned how to use the box. Today we're using the same thing. Think of the CF, big CF, and CF as two terms, right? That's why we put them up here on the side of the box to indicate that this is the first term. So technically it's a binomial times a binomial, but we're applying this in a science sense. Here's the first question that's being asked. Write an expression for the genetic makeup of children of two parents that are carriers of the cystic fibrosis. Now, if you look at the box and examine it carefully, first of all, you see that when you see big CF, those are the abnormal genes. The small CF means the normal gene. Of course, when you crossbreed, in this case, two big CF will definitely tell you that you are affected if you are the child of this particular case. And then you also have the chance of being a carrier, but not being infected yourself. You know, carrier means it's like it's lying dormant in your body. It doesn't show, but if you have a child of your own, that could pass on to your next generation. So in a sense, it's not good either. So sometimes that's why parents, who want to have children, who want to go to gene therapy or whatever, they want to look up to see what's happening first before they decide to have children, just to be on the safe side, because you want your child to be happy, okay? But you can kind of see, two big CF become CF. You have CF, big CF, small CF becomes CF, big CF, and small CF. Same thing over here, it's just multiplying, as you can see. Two CFs become two small CF, okay? Nothing strange here, right? This is what we've done yesterday. But what you see here is that, once again, if you look diagonally, are they like terms?
Yes.
Yeah. And these two are indications of carrier. That means children in this category means they don't show the symptom of the disease, but they are the carrier of the disease. Does it make sense?
Yeah.
Okay. Now, the question's asked. Write an expression for the genetic makeup of the children of two parents that are carriers of the cystic fibrosis. So in this case, how do you write that expression to represent the carrier? Yes? You have to indicate small or big CF.
Oh, big CF. Another big CF. Power of 2.
Power of 2, you said?
Yes.
Carrier? Look at the carrier. This is affected.
Oh.
This is carrier. And this is not carrier, not affected.
Oh, okay, so big CF and then small CF.
Okay, so you said big CF and small CF.
Power 2?
Power of 2? We're combining like terms, right? Think about this.
Times 2.
Times 2. Like that?
Yeah.
There it is. So that's the expression to represent the carrier. We have two set of those. So therefore, it's an expression to represent the carrier of the disease. Okay. That's simple enough, combining like terms. Here's the last part, which is very simple, I hope. What is the probability that a child will not be affected and not be a carrier? Not affected and not a carrier. What is the percentage of that? Probability of that happening? 50-50?
Oh, we have to do a percentage? Oh,
Probability in this case.
Yeah, when she said 25.
25%, because it is exactly 1 out of 4 chances, right? So 1/4, or you convert that, it's exactly 25% chance. So
I put a low chance.
if you're a child, yes, you can do that. If you're a child of these parents, you have a 25% chance of not being a carrier or affected by the disease. But notice that you are at a higher risk for being a carrier, and you have also a very small chance of being affected yourself. Okay? And so the safest way, of course, is, well, let's look at another case. Let's just see.
What's the difference between a carrier and affected?
Okay, affected means you will see the disease, you have the symptoms right away.
A
carrier means you don't have the symptom, you just have a carrier of the gene throughout your life without seeing anything.
Okay.
You're not affected. See it? That's the carrier. So imagine if you have another set of parents. This parent has the carrier gene, and the other one doesn't have anything. So let's calculate a little bit here. What is this going to become? Big CF, small CF. This one? Small CF and small CF. This? Big CF and small CF, right? And this? Small CF. Okay, so you look at this right here and you say
50-50.
50-50 chance. But the offspring of these two, will the offspring be affected at all? Affected, meaning like,
No.
yeah, but only carrier, right? So there it is. So a smaller chance of being a carrier. Oh, it's 50 chance of getting being a carrier, and 50% chance of not being affected at all, which is a pretty good case. That's why people want to, pay big money for this. They just want to examine their genes, see everything's good. Okay, any questions so far? All right. So now today I want to introduce to you a special kind of product, guys. And here's a special product number 1, which will help you multiply binomial faster. Okay? There's a pattern I hope you will recognize later on. And for the special product today, I like to call this the squares of sum or difference. By the way, of course, you know that the sum means additions and difference means subtraction. Okay? So, special product case number 1, square of sum or difference. I'm going to show you the case number 2 tomorrow, which has to do with the product of sum and difference. Well, that's for tomorrow. Don't worry about it. But for today, I'd like to do some examples with you. Hopefully you'll see something here. But first of all, let's review this a little bit. Do you remember how we write this? What's a squared again? How do you?
A times A.
Okay, a times a. So I hope that you will never, ever give me a case where you say a times a is a. Not going to happen anymore, right? Because clearly you see that a squared expanded to a times a. So that means if I give you a times a, you should be able to go back to the original form, which is a squared. Right? So please do not ever tell me x times x is x. Not true. X times x is x squared. Make sense? Okay. Now, if I write it like that, it means you expand it 2 times. What if I write it like this? Now what then? What does it mean?
X
Okay, I heard distribute.
squared plus
Yes?
It would be x squared plus 3 squared.
Okay, so here, that's basically what you said, distribute, right? So I heard people say this. So you basically say x squared plus 9. Is that true? Is that what you say?
No.
Okay, now let's think about this for a moment.
Yeah.
We agree that x plus 3 squared means, if you expand it, should it be like this? Is that correct?
Yeah.
So I want to prove something right now, and hopefully it will make you be aware of what you're doing right now. If x plus 3 times x plus 3, what kind of box do we need here? What kind of box do we need? We're multiplying. We're multiplying here. 2 by 2. 2 by 2. Watch what happened. Yeah, this is the box we're talking about. Now, so because they are exactly the same, we can just write x plus 3 anywhere we want, right? X plus 3. So let's multiply. This becomes what? X squared. This? 3x. This? 3x. This? 9. Like terms? Yes, right there, right? So if we write it, don't we see x squared plus 6x plus 9? And clearly, x plus 3 squared, after expansion, using the box, you should have this answer. X squared plus 6x plus 9. Now go back to what you gave me before. X squared plus 9. So is that correct? You see it? You see the difference? You're almost correct though. Except you're missing what? The 6x. Because you forgot. This is a 2 by 2. You got your x squared and a 9 right here, but you're missing the other 2 boxes. See it?
Yeah.
So the safe bet right now is write it out, use a box.
So on the test, it's going to be like that and not like that.
I would give you like this. I would definitely give you in the square term, but you need to remember if this is being square, you have to write it twice, right?
I got a box.
And then you're going to use the box to use it, to expand it. Okay? But so this is not correct, guys, so don't even try to do that. Don't assume that because there's the power outside, we can go ahead and distribute. No, no, no. Distribution, as you can see, applies to this. We can certainly distribute like that, but not the power. You see the difference here?
Yes.
Not the same. This is x plus 3 squared. This is twice of this. That's why we can distribute, not the power. We can only distribute the power when it's layered. Remember that case? Okay, I'm showing you here. You were mistaking it for this case right here. When it's like this,
Oh,
then
power
you would do that.
multiplied power.
Aha. So you only distribute when that happens. But
There we go.
notice here, even then, you should recognize that this is all linked up by multiplication. That's not the case. That's actually 2 terms. This is 1 whole term. So it's okay for you to do this. But this is 2 separate terms. You cannot distribute powers at all. You only expand, but not distribute. Okay? So hopefully that's clear. But if you are in doubt, expand it, please, and use the box to multiply. Don't try to guess anything. Okay? So here's another one. Oh, by the way, this is called the square of a sum. You know why it's a sum? Well, square of a sum. Square of a sum. See that? That's why. So let me give you an example of a square of a difference. Watch this. How do you write that?
2x minus 7 and then parentheses and all that.
Very good. So don't hesitate to expand it. Please keep your first example right in front of you because after this example, I want you to do a quick comparison a little bit. Okay. So notice that we have 2x minus 7 squared, so therefore I expand it and write it twice. I can now go ahead and use the box for it, right? Here's my box, a 2 by 2, and because they're exactly the same, I just write 2x and negative 7, 2x, negative 7, right? Okay, what do you see for the first box?
4x squared.
4x squared, good. 4x squared. This one,
49.
negative 14x.
Oh, wait. Or
Yeah, I'm sorry, you try to get the last box, fine. But negative 7 times 2x? Negative 14x. And negative 7 times negative 7? 49. Like terms? Right there, right? Okay, so your answer should be 4x squared. Next. Minus 28x plus 49. Okay. So you see the difference between the previous and this one right here? The other one is a sum, right? That's why the middle term is a plus also. And this one's the difference. The middle one is a minus. But do you notice that the first and the last term stay positive all the time? Why?
Because you square it.
Because you square it, right. Because when you square a number, in this case, it will stay as a positive. Now, I want you to look very carefully here. Not that I want you to stay away from using a box. A box is actually a perfect tool for you to get this simplified. But do you happen to notice a pattern?
Yes. Yeah.
I know, Jennifer, but any of you notice a pattern?
No.
Okay, let me just go ahead and bring this
Wait, hold on, let us think about it.
Yeah, think about it. I'm not going to rush.
Wait, pattern.
But I want you to look at this right here and look at this right here. You see, when you first give me the answer, you're almost there, but you're only missing the middle term, right?
Yes.
So I hope that if you see a pattern, then you can actually try to not do the box.
Oh, you.
Shh. Think carefully before you say anything.
Oh,
You see a pattern. You see a pattern.
Oh.
You just.
What is it?
You just. Oh.
Santina,
I,
yes.
I know.
Well, what's pattern?
Okay. No, I think this is it.
Okay, go ahead.
I did 2x times 7, or yeah.
Say.
2x times 7 and wait, hold on. square that or times that.
Square.
I don't know.
What do you think? What do you think? Anyone want an idea of that? Yeah, Nicholas.
Well, I mean, you like multiply 7 and negative 7 and negative 7, and you get to plus 49.
Okay, so you got this part. Okay.
And then you like, wait, let me think. And then you wait, hold on. You multiply 2x and 2x, and you get 4.
X squared.
Okay. All right. So you got that. So you basically got this box and that box.
And then wait, and you get the 2, and then you put the power of 2, and you multiply that by 4, and then you get and then you times 4 by 2 negative 7, and then you get negative 28x. Wait.
Not quite. Any other?
Close enough.
Okay.
I think I got it.
Okay. One more try. That's okay.
Okay, one more shot for me.
Okay. Go ahead.
I did. I think 2x times negative 7, and then I times it by 2, which would be negative 20.
So basically, this is what you're saying. Do you notice that the pattern says this? You can certainly get the first term and the last term easily by squaring the binomials, right? 2x squared is 4x squared. Negative 7 squared is positive 49. That's easy. The middle term, however, takes a different turn. And he said this. I'm going to go and take this first term, multiply that by the second term. 2x times negative 7 is negative 14, and then you said to multiply the whole thing by 2 or to double it up.
Oh.
Why double? Because it appears twice in the box.
I got it.
See that?
I get it.
So if you can actually see that, then you don't need the box because you are calculating it without the box. You see it why.
Got it.
So 2x times negative 7 is negative 14x, right? And then you double it up, which becomes negative 28x. And there you have it, right there. See that? So now you can actually expand it just like that without having to use the box at all. Questions so far? Well, let's test this to see if you actually really understand it. Here we go. Can I erase it?
Wait,
Oh.
I'm not lying.
We're done?
Okay, I'm done.
Okay. All right, let me zoom in a little bit.
Hey. My pen?
Okay, here we go. So let me erase this. I need to calculate, to calibrate this thing.
Is there different colors?
Yes, I did. Did you notice? You notice I changed the color?
Guantanamera.
Okay, thank you,
I was thinking
Isaiah.
about that yesterday.
All right, here we go. So here's the problem. I have. Oh, come on. Stop that.
Can you erase that mark?
It's okay. All right, here we go. I have. Come on, it should work.
It does bug me.
There. So without using a box, think for a moment. Without using a box. Now, by the way, if you want to use a box, sure, you check your answers, fine. But for those of you who feel comfortable now that you see a pattern, what do you do? Yes.
Okay, so multiply.
What do you do first?
You distribute the two.
No distribution. I don't want you to make that mistake of distribution. No, we don't distribute power to the terms like that.
You use multiply.
No.
Yeah.
Yes, you have to square the 2x.
Okay. So, in other words, we identify the terms inside, right? By doing what? Circle it. Is that true?
I think I got it.
We got 2x here. We got positive 3y here.
Yeah.
Then now you would square it. What is 2x squared?
4x.
Okay. And then what is 3y squared?
9x. Wait.
9y.
Oh.
3y squared is 9y squared, right? So we got the first term, we got the last term. The only thing that we're missing now is the middle term. And so we go back to what we circle. See, the important thing is we need to identify our two terms. What we circle, we now what? Multiply to become 6y, xy, very good. 6xy, and
Times by 2.
times by 2 to make it 12xy. There it is. And you can kind of see why.
That's 2.
See? But if you don't believe me, here's the box. You got 2x, 3y, 2x, 3y, 2x times 2x, 4x squared. 3y times 3y, 9y squared. 2x times 3y, 6xy, 6xy. Like terms, 12xy. Yeah? There. That's all we're doing.
But then there's 2x's and 2y's, so wouldn't it be squared?
No, we're combining like terms. XY is a like term. See, XY, so we have 6 XY.
Okay.
Another 6 XY, become 12 XY. Okay? Any question on that? You see the pattern?
Yeah.
Cool. All right. Why do I have to keep on calibrating this thing?
I don't like you.
It doesn't like when your collar's broken.
No, it's sad, but oh well, it's okay. All right. See if you can actually get the answer fast on this one. Ready? Raise your hand if you think you have the answer.
Hold on, let me do
Oh
the
my
game.
gosh.
I heard, dude, who raised their hand already? I just seen somebody's hand go.
It was Nico's.
No, it wasn't.
He can't even write the phone down.
Think carefully.
Hold on.
It's
I need
A bit trickier.
Wait.
Hold on. The answer.
You have negative 11ab plus 7a, everything squared.
I know that
So
it's 22.
think about this for a moment and see what you have.
49A, and then the other one,
Just work it out. Work it out.
the middle one is 77.
Well, while you work it out, let me calibrate this thing. Hold on.
Why
I
you?
don't know
Why you?
keep on doing this.
Why again?
Okay. All right.
Got it.
Okay. All right.
I think.
11.
So strategy here. What do we do first?
Circle.
Circle. Very good. So we're gonna go ahead and circle. Circle. Don't forget, when we circle, we also include the sign in front of the term. That's just something that we do all the time. And now, here's the tricky part, and I hope people will actually get this. What is a negative 11ab square?
Negative 22.
22.
Square. We're talking about square here.
22.
Oh, it's 121.
What?
So this whole thing square is just
Oh wait, no.
No.
It's
Just that one.
What is it?
121 AB squared, right?
No, it's not negative.
I remember the
It's
thing
not
you
negative.
did
It's not negative.
Wait. So I got several answers. One said 121. One said 121ab square.
No.
No.
Just
And the other one is 121a square b square. Which one's the correct one then?
None.
None?
None.
Why? What happened?
They squared the A and B. You're not supposed to.
Oh, let me ask you this question. You know that we're gonna have to take this and square it, right?
Yeah.
That means it will appear twice,
Yes.
right? Oh, sorry. It will appear twice.
Stay with that negative sign.
If it appeared twice, what happened?
121 AB.
AB.
What is a times a? We go back to that same problem again.
Oh, AB2 and B2.
Okay, whatever. It's A squared, B squared.
Thank you. So this is the correct one.
Yeah,
Isn't it?
it's not like
See it?
RTD.
You gotta be careful. When you're swearing,
R2D2.
that's what's happening. Gotta check carefully here. So we know for a fact,
I was wrong.
and it go back to Isaiah questions earlier on this one. This is negative 11ab squared. That means this whole term is being squared. So that square is being distributed. That's fine. That is actually okay.
Yeah, that's what
So that means it is 121a squared
Positive?
b squared. Yes, it's positive because
Oh, yeah.
notice that the negative stays inside the parentheses.
I knew it.
Okay, so we got that front term. What about the last term? 49.
Earth.
Let me just write it again. 49a squared, right?
Yes.
Okay, what about the middle term?
2 times
Okay.
See what I mean?
What times what?
11.
Negative 11.
150.
Well, let's multiply the number first. Negative 11 times 7.
77.
Negative 77. And then what?
154. Oh, multiplied by 2.
Times 2, which is?
I think 154.
Okay, so negative,
Yeah.
let me just use a different color. Negative 154 you said, right?
Yes.
Now here's the tricky part.
A squared B.
Ah, a squared b. Very good.
B.
Very good.
How?
How's it a squared b you said?
Not 2
Because
B.
first of all,
Thing.
when you multiply, what is a times a?
A
A
squared.
squared.
There's
See that?
no B squared.
There's no b, so it's just b.
There's no B. Yeah.
Okay, now,
Square.
this is the part where I said this. If you can't see it like that, just do me a favor, set up a box. Okay? That means you have 11, negative 11ab right here. You have 7a right here, negative 11ab. And you have 7a. It's a lot easier when you see it like this, huh? Then fine, do it like that. Negative 11 times negative 11, 121. A times a squared. B times b squared. Do it like that, it's fine. And over here, negative 77, A times A squared, of course B just by itself, and it's just gonna be the same. A squared, B, 7 times 7, 49. A times A squared. And look, that's what we got. Same exact thing. Okay, what question do you have now?
No
And that problem.
No questions.
Feel good?
Yeah.
Okay. Alright, let's stop at that.
They might real quick. They might go.